The question states, what is the freezing point of a solution that contains 10 grams of glucose and 100 grams of H2O? The Kf for water is 1.86 degrees Celsius per molality. So, all of this was given in your problem. The formulas down here were not. So you have to basically know that when you're dealing with freezing point, you're going to be needing to use the formula I have here, which is the change in temperature for freezing equals Kf times molality. Remember again, little m means molality, big M means molarity. So we're dealing with molality. So the formula for molality is moles of solute over kilograms of solvent. So first of all, in this problem, we can see that since we're using this equation, we only have one variable to solve for because the Kf value for water is given to us already. So we can plug that in right here when the time comes. However, we do not have molality yet. So let's calculate molality. So what is our solute and solvent in this equation or in this problem? So the solute is going to be the glucose and the solvent is going to be water. And we know this because water is always pretty much, majority of the time is always going to be your solvent. So the thing left over, glucose, is going to be your solute. So let's first calculate the grams of glucose. So we have, it states in the problem we have 10 grams of glucose, and we're going to multiply that by its molar mass so we can get a mole value. And the molar mass of glucose is, is 180.16 grams. So when you do that, the way you set it up, you can cancel your grams and you'll get moles. So when you multiply this problem right here, you will get 0.056 moles of glucose. So right now we have the very top part of our molality problem. Now we need to figure out the kilograms of solvent. Well, we've already established that our solvent is water, and we have 100 grams of water. However, we need that in kilograms, so we'll do a conversion. Grams goes on the bottom, kilograms goes on top. There are 1,000 grams in 1 kilogram. So let's cancel our units, and we're left with kilograms. And then when we multiply this, we get 0.100 kilograms of water. So now we just set up our formula correctly. So our moles of solutes over our kilograms of solvent, and we solve. And when we divide these two, we get 0.56 molality. So again, now we have our molality value. So basically, to find the change in temperature, we just multiply our molality times the Kf. And I find it always important to line up our units so you can cancel them out. So molalities cancel and you're left with degrees Celsius. And when you multiply that, you then get 1.04 degrees Celsius. However, you may think that you have now solved the problem, but what you solved for was a change in temperature. So to complete this problem, we are now going to have to use the change in temperature to determine the actual freezing point. So the freezing point of water is 0 degrees Celsius. And we've determined that the change in temp was 1.04 degrees Celsius. So basically you take 0 degrees Celsius and you minus that times, or minus it times, minus the value of the 1.04 degrees Celsius, and you will get negative 1.04 degrees Celsius. And that is your final answer for the freezing point of the solution.